All right, so here's day 2 of the notes. We're going to switch from having logarithm problems to exponential problems. Nope. Okay, so the first one is probably a little bit more familiar. We've probably seen one like this before. So we're looking at base 2. We're going to change the right side to base 2. So we get 2 cubed, and then we drop the 2's, and we get x minus 5 equals 3. So I believe maybe a couple of the beginning ones of the homework set the classwork set, they might have this. But the goal of this homework is to show what happens when we can't give them the same base. So we can't make 10 base 2. So what we're going to do is we're going to take the natural log of both sides. So one of the rules we had said, hey, we could take the natural log of both sides. Okay, and then we're going to pull our x down as a multiple. And then we're going to divide. And before, my math lab wanted you to leave it alone. Oops, I didn't want 10. I wanted 2. And now they want you to divide and put it in your calculator and round to 3 decimal places. So 3.322. So pretty easy. We're going to, again, take small steps forward since we put it into 2 days. So 8 to the negative x equals 1.2. So again, we're going to take the natural log of both sides. We're going to bring this negative x down. And here, I'm going to not only take the natural log of 8, but I'm also going to take this negative sign as well. So I'm going to be left with just x. I'm going to have the natural log of 1.2, negative natural log of 8. And what I normally do is I put everything in the calculator except for the negative sign, and I just attach a negative to the answer. So I get a negative 0.088. Okay. So again, another step forward. Okay, so this one is, we don't have one term on the left side, we have this extra multiplier. So what we're going to do is divide both sides by 5. Okay, so anytime there's a multiplier out front, we want to get rid of it and then divide. Okay, so now we're going to take the natural log of both sides. And then I'm going to, again, take this down as a multiple. So 3x, natural log of 2, natural log of 8/5. And then, again, I'm going to take everything that's not x. So I get x, natural log of 8/5 stays on top. 3 and the natural log of 2 goes on the bottom. And I get 0.226. All right, so again, we're going to take it a step up. 3 to the 1 minus 2x equals 4 to the x. Again, first step, unlike the last one, we're going to take the natural log of both sides. We're going to pull 1 minus 2x to the front. We're going to put it in parentheses. And don't ask me why I didn't do that here. That was definitely a boo-boo there. This should have been the ln of 4 to the x here and x ln of 4 here. Okay, so because I have a parentheses on the left side, I do have to distribute the 1 and the 2x here. So I'm going to get 1 natural log 3 minus 2x natural log 3 equals x natural log of 4. So now I have x on both sides. So I need to make sure they're on the same side. I have this subtraction sign, so I'm going to add that whole term to the right. So the natural log of 3 equals x ln 4 plus 2x ln 3. And then I'm able to factor this x out. So there's an x in each term. I can factor it out. In the front term, I'm left with ln of 4. In the back term, I'm left with 2 ln 3. And then I'm going to take that whole parentheses and divide it. ln 3 divided by ln 4 plus 2 ln 3 equals x, and that is 0.307 as a decimal. So a lot of work here, a lot of little pieces that you have to be careful about. Okay. We get 1.2 to the x equals 0.5 to the negative x. All right, so this one seems easier than the last one, but you're going to see that this one has a little interesting twist at the end. So the natural log of 1.2 to the x, the natural log of 0.5 to the negative x. And at this point, if you've done enough problems, some students go straight to this line. X ln 1.2, negative x ln 0.5. And I'm okay with that. If you want to skip this line, that's fine. Okay, you can skip that line. All right, so again, I have x's on both sides, so I need to move them to the same side. So I'm going to add the right side to the left. And I get 0. Okay, so there's nothing left on the right side. I am going to factor the x out. ln 1.2 plus ln 0.5 equals 0. And you might see where this is going. 0 over natural log 1.2 plus natural log 0.5. And 0 divided by anything is 0. Okay. One last one. This one's one that you'll do on the homework, but wouldn't be on a test. It's a tricky one. So 2 to the 2x plus 2 to the x minus 12 equals 0. So what we're going to do is we're going to make 2 to the 2x equal 2 to the x quantity squared. Okay, so if we do that, we're going to now have 2 to the x squared plus 2 to the x minus 12. And we're going to have a quadratic. And so we can now go to the right side and see that we have a u squared plus u minus 12 equals 0. So we could essentially substitute 2 to the x. So 2 to the x equals u. I'll write that up here. 2 to the x equals u. And then we could solve that. We get u minus 3 and u plus 4 equals 0. And u equals 3 or negative 4. Okay, so we would substitute that back in. So we get 2 to the x equals 3 and 2 to the x equals negative 4. okay? But we can't have logarithms that are negative numbers. So automatically, this -1 gets crossed off because we're going to immediately go ln 2 to the x equals ln of 3. Well, this one would have been ln 2 to the x equals ln of -4, and we can't have an ln of -4. So again, cross that off. So we're going to get x ln of 2 equals ln of 3, x equals ln of 3 over ln of 2. So x equals 1.585. So again, tricky, we're going to involve u substitution, something that's great to work on for a homework set and follow along with what we're doing, but not so great to put on a test.